Hi everyone, in this video we're going to go through 9F, differentiating rational powers. So question 3, we don't actually have to use the chain rule, but we will for the other questions. So we might just do 1 from 3A and then get a little bit more practice in with the chain rule. All right, so what we have to do in question 3 is find the gradient of the tangent to the curve for each of the following as stated value for x. All right, so we've got our function. So we're going to find the derivative of that, and then you just substitute in your x value into your derivative function. So we've got f of x equals x to the power of 1/3. So f dash x, so remember you've got two types of notation, dy dx or f dash x to represent your derivative. So I've just used f dash x because the function is defined as f of x as opposed to y. All right, so we've got 1/3 x, and then we just need to reduce 1/3 by 1. So it is -1, just like we've been doing. Now, if you do struggle with fractions, just write it as a fraction. So 1 as a fraction is the same as 3/3. And the reason I did 3/3 is because you want to have the same denominator. So I want these to be the same denominator. So if it was to the power of 1/4, I would do 1/4 minus 4 and 4. Okay, so 1/3 x, so that's -2 on 3. And we're going to substitute in x equals 27. So we're going to do f dash 27. Now I'm just going to put it in brackets just because I don't want to get things mixed up. All right, so you should be able to do to the power of -2 on 3. Okay, it is something that you don't really get a lot of practice in with this skill, but it is something that you're expected to be able to do. So don't do 1/3 times 27 yet. All right, with the power takes priority. All right, so to the power of -2 on 3, we need to split that 2 on 3 is the same as 2 times 1/3 or 1/3 times 2. So it's the same, all right? I haven't really changed it, but when we're doing 27 to the power, and I'm not going to worry about that negative just yet, 2/3, you can either rewrite that as 27 to the power of 2, then take that to the power of 1/3. And when you think about it, 27 to the power of 2 is pretty hard to do, okay? So, or you can do 27 to the power of 1/3, then square that, which is going to be a lot easier for you. All right, so you're splitting the 2/3 into a unit fraction. So in this case, it's 1/3, and to an integer, which is 2. All right, and then you're able to do it a lot easier. Obviously, this one here is going to be easier to do than 27 squared. All right, that's just ridiculous. All right, so I might just finish it over here, so then we can just write it over there. So 27 to the power of 1/3, so that's the cubed root of 27. So what number do you multiply by itself 3 times to get 27? So that's 3. So 27 to the power of 1/3 is 3. So it's a cubed root. Okay, so remember, I might just rewrite it here. So the cubed is the same as the cubed root of 27. Okay, and I should just write squared. Okay, so that's 3 squared, which is 9. So what we've got here, because it's a negative, it's going to be times 1/9 because of that negative power. All right, so then that becomes 1/27. Oops, yeah, sorry, I was just making sure I multiplied by the 1/3. So when you're multiplying fractions, you multiply the numerators and you multiply the denominators. There we go, 1/27. Whoops. All right, so if you need help with B, C, or D, just let me know and I'll have to help you in person because I'm going to move on to question 4. All right, so here I can already see that we're going to be using the chain rule. So for A, we've got the square root of 2x plus 1. Now that is the same as 2x plus 1 to the power of a half. Now you should know how your radical, your square root or your cubed root relates to your index. So the square root is the same as x to the power of a half. The cubed root is the same as the power of a third. The fourth root, same as the power of a quarter, and so on. Okay, so I'm rewriting that as 2x plus 1 to the power of a half. So we're going to use the chain rule, so let u equal 2x plus 1. And then du dx is equal to 2. And if we go back, y is equal to u to the power of a half. So dy du is equal to a half u, and then decrease that by 1, so it's going to be negative a half. And you can substitute the u back in here if you like, or do it at the end. So 2x plus 1 to the power of a half. All right, so dy dx, we just multiply. So we're going to have 2 times a half. I might actually write it here, but I know that actually just cancels out. And then we've got 2x plus 1 to the power of a half. So 2 times a half is 1. So then we're left with 2x plus 1 to the power of a half. All right, and I just realized I forgot to put the negative in here, which meant I forgot this one here and here. All right, so we do need to just fix that up. So that's going to be 1 over. And doesn't matter if you leave it to the power of a half. Now, I would say it's tidier to leave it as a square root. 1 over 2x plus 1. All right, and so it's 1 over because of the negative power, and it's a square root because it's the power of a half. All right, let's have a look at maybe E. So I might do E over here. Should have a bit more order to how I write them on the screen. All right, so we've got x squared plus 2 over square root of x. So we haven't learnt the quotient rule yet, so we're going to use the chain rule. Now remember that x to the power of, square root of x is the same as x to the power of a half. But to differentiate this, I do need everything on the top. So that x to the negative half I can bring up as x to the power of a half can come up to the numerator as x to the negative a half, and that's multiplying x squared plus 2. So it might have been a bit tricky not recognizing that. All right, and then just expanding that bracket. So we're going to have x, and then we add our powers. So negative a half plus 2 is 3 on 2, not negative 3 on 2. And then we've got plus 2x, the negative a half. All right, so we're not actually going to be using the chain rule for this one. Oops, what am I doing? All right, so now we can do, I might do it over here because I feel like I'm continuing on. All right, so let's let y equal this. So dy dx is equal to 3 on 2x, and then reduce your power, so it becomes a half, plus, and then we multiply the 2 by a negative half, so it's going to become negative 1 x, and then reduce your power by 1, so it's negative 3 on 2. let's just tidy it up a little bit. So that's going to be 3 square root of x on 2 minus, then we've got the negative. So that's going to be, if we're going to do it as a square root, the square root of x cubed. Now, your answer in your textbook might look different to that, and we might even bring those fractions together. So just remember that your final answer may differ to what it is in the textbook. So let's have a quick look at what it is in the textbook. Which question am I doing? 4E, wasn't it? All right. Okay, so it did write it pretty much the same. I put the square root of x on the numerator with the 3. So the point I was just making is I was kind of hoping it would be a bit different. You know, they might leave it as a rational power, so a fraction. You might not have a square root on the denominator. They might bring it to one fraction. Okay, so just make sure you don't automatically assume that you're wrong. If the answer does differ, keep working to see if you can get to that answer. All right, I did say question F might be a bit tricky. Actually, I might move on. Question F is very similar to E, so I might move on. All right, so question 5, we've got to show that question. So probably not the case with this one, but any show that, you just got to pretend that you haven't got the answer, and you got to show the working to get that answer. But this is a little bit different because we've got a, we've just got it in the generic form with A. Yeah. Okay. So we're going to find the derivative of this. So show that. Okay, so let's just say y is equal to the square root of x squared plus or minus a squared. So dy dx, and it's told us what it's equal to, which is this. Sorry, I've got a very itchy throat this morning. So we know the derivative, or they want it in that form. Okay, so we've got dy dx. I'm just going to rewrite that first as x squared plus or minus a squared, and that's to the power of a half. So I'm going to find d dx, or dy dx, we're going to let u equal x squared plus or minus a squared. So du dx is going to be 2x. And then if y is equal to u to the power of a half, then dy du is equal to a half u to the negative a half. And then just substituting u in. So I might do that at the end, just because I'm running out of room. So dy dx, or d, the reason they haven't put y in here, because the expression, or it's just an expression, it's not an equation, y equals. Yeah, but I tend to just write y equals and then use dy dx. All right, so then we've got 2x using the chain rule times a half. U is x squared plus or minus a squared to the power of negative a half. All right, so 2 times a half is 1, so then we're just left with x there. And then this is to the power of negative a half, so it's going to be 1 over, and then that half becomes the square root. So x squared plus or minus a squared, and then we're nearly there. Just multiplying your numerators and your denominators, so x over the square root of x squared plus or minus a squared. All right, and then the second one is probably very similar to that. Yeah, so I'm not going to do B as well. All right, question 7. Just going to see how many questions we got. All right, one more. Question 7. Let's do C, and then we'll finish the video. So we've got the fifth root of x squared plus 2x. So this is the same as x squared plus 2x to the power of 1/5. All right, so we're going to let u equal x squared plus 2x. So du dx is equal to 2x plus 2. And we're going to let y equal u to the power of 1/5. So dy du is equal to 1/5 u. 1/5 minus 1 is -4/5. All right, and I'm going to do the u at the end. So dy dx, or d dx, is just putting it in brackets. So 2x plus 2 times 1/5. U is, what is u? X squared plus 2x to the power of -4 on 5. And let's just, what can we do? All right, 2x plus 2 on 5. All right, so I've just multiplied these first two terms together. And then we're going to do the other bracket, so times, because of the negative power here, it's going to become 1 on, and then x squared plus 2x to the power of 4 on 5. And all right, multiplying your numerators and your denominators. So we're going to have 2x plus 2 on the top, and then on the bottom 5x squared plus 2x to the power of 4/5. I kind of think that's got it. Oh no, right. Okay, so with this question here, I'm going to check again just with our answer. So what were we doing? 7C, wasn't it? 2x plus, oh, so it's written it as the fifth root. Okay, so see how I left it as 4 on 5? I probably should have written it as the fifth root. So let's go back and do that. All right, so 4 on 5 has just been separated to its unit fraction times the integer. So the power of 1/5, remember, is the fifth root. So that's what's happened here. So we're going to keep 2x plus 2 on the numerator. The 5 stays there. And then we're taking the fifth root of x squared. Make sure you put it in brackets because all of that is to the power of 4. And just make sure your vinculum, the line separating your numerator and your denominator, goes all the way, and your square root sign goes all the way as well. That is extremely important. Don't think that I'm being pedantic. If you didn't do that in your exam, this case it might be different because you've got a bracket there, but you do need to cover everything. All right, I'll leave it there. Bye, guys.